and a nickel are each tossed once.
Mhm.
So they're distinctly two coins.
Mhm.
Right? Explain whether the outcomes for the two coins are as follows. Oh, well, you got that one right, but was that through eventually getting it because there's 5 choices and you picked the right one?
I think that was more of a coincidence rather than
Okay.
anything.
Okay. So 2 events are independent, right? If the probability of the first event has no connection to the probability of the second one. So an example of 2 independent events could be like this. You throw 2 different coins in the air. The first one could be a head or a tail.
Mhm.
The other one could be a head or a tail. If the first coin is a head, does that have any effect on the second one?
No.
No. So that would be an example of independence, right? 2 events being independent of each other. There are a number of different tests that we can use, numerical tests that we can use to show independence. So I'm going to go back out for a minute and show you what those would look like.
Perfect. Thank you.
So for instance, if event A and event B are independent, then the following is going to be true. The probability that A and B happen will be the same number as the probability of A multiplied by the probability of B. And we actually use that property to calculate things like the ANDs. Right?
So that's
So
when you multiply them.
That's when you multiply them. So the chances the first one's ahead and the second one is ahead is probability the first one's ahead is a half times probability the other one's ahead, so it would end up being a quarter.
Mhm.
Right? You also have this as a test. That's one of the tests. The second test says the probability of A given that B has happened is the same thing as just finding the probability of A. So that's using that funny symbol there is for given. We call these conditional probabilities. So what's the probability that the first coin was ahead, given that the second coin was ahead? Well, I don't care what the second coin is. It's still the same event. It's still whatever the probability of A happening is. So these are independent, right? Now, let's talk about mutually exclusive now.
And I think that's the one I'm having the most issue with. Because I feel like they're the same thing from reading it. They're very similar.
They can, in some situations, be the same. In other words, inclusive. It is possible for 2 events to be mutually exclusive and independent. That's quite common, but not a guarantee, right? So technically, 2 events are mutually exclusive if events in A have no common values to events in event B. That's a little vague, so let me put some meat on that. Let's do cards, because they're the best ones to imagine. If you had A, the event is that you picked a red card, and B is the event you picked a black card. Then red cards and black cards have nothing in common. If you imagine a little visual, that circle's where all the red cards live. That circle is all the black cards live. We would say A and B are mutually exclusive. Now, they may be independent of each other, but not necessarily so.
So what would be another example of the mutually exclusive?
How about And then I'll show you one that's not mutually exclusive. Sometimes in the not version is easier. Suppose A was you got a king, and B was you got a queen. These two events are mutually exclusive. If you're a king, you can't be a queen, and if you're a queen, you can't be a king. If you're red, you can't be black. If you're black, you can't be red. These are mutually exclusive events. Now, if I did, what's the probability that you got a king and a queen? The answer to that would be 0.
Because you can't have both at the same time.
Can't have both. But if I said to you, what is the probability that you get a king or a queen? Well, that's different. If two events are mutually exclusive and you want to get an or story, king or queen, what you can do when they're mutually exclusive is it says that A or B will be the probability of A add the probability of B. Not multiply, but add. So if I wanted to find out what's the probability I get a king or a queen, I would say, well, in a deck of cards, there's 4 kings and there's also 4 queens. So that would end up being 8 out of 52, which I think simplifies down to 2/13. And 8, right, 4 kings plus 4 queens. I'm just ran out of room, so I just added them up. Now, you can see that when you talk about the and, you need things to be independent so that you can calculate these probabilities by multiplying. But when they're mutually exclusive, you get the answer by adding the 2 probabilities. You see, there's quite a big difference between adding 2 things to get the answer and multiplying 2 things to get the answer. Very often when we talk about independent events, the 2 events don't even need to be like each other. But when you do an OR event, the 2 things have to be at least similar to each other. They have to be the cards from the same deck of cards, right? Things like that. They have to be days of the week from the same week, you know, things like that, right? They have to be connected in some way. Now, if I said to you, well, what's the difference? Before we go there, let's look at not mutually exclusive. Suppose A was getting a king and B was getting a red card. If I draw a little circle and I put all the kings in here, there's actually 4 of them, right? And if I do all the red cards, there's a lot of them. But do you notice that there's an overlap? They're not mutually exclusive because isn't one of the kings red? Well, actually 2 of the kings are red. You know, there's an overlap there, right?
Yeah.
So that's what not mutually exclusive looks like. So if they're not mutually exclusive and somebody says to you, the OR question, what's the probability you get a king or a red card? Then it gets a bit messy because what you have to do is you find the probability of getting a king and you add the probability of getting a red, but then you take away the probability that you get both. So I did that. If I wanted to know this probability of getting a king or a red, there are 4 kings, right? The bottom number is 52. There are 4 kings. There are 26 reds, but there are 2 that are in both camps. And you see the takeaway 2, the take away the probability of both is so that you don't double count, right? You don't double dip and you count a king, but then you count it as being red, and in which case you're really counting something twice and you shouldn't. So do you notice that mutually exclusive events are typically used in or questions, and when they are mutually exclusive, you add them. But when they're not mutually exclusive, you still add them, but then you have to compensate with this takeaway both.
Mhm.
Is that helping any?
It does help a lot.
Okay,
So for
so
that one with the coins, it would be similar to the one with the king and the queen because it can only flip to one side.
right, but there's two different coins, right? There was a dime and a something else, wasn't there?
Yeah, whatever the American coins.
Right, so whatever they're called, yeah, those guys, right? So in those cases, the two things are not like cards from a deck like these are. They're two separate objects. One's, a big coin, and the other one's a little coin, right? They're two different coins. So we would be talking in that story about independence. Are the two things independent? Now, are they mutually exclusive? Well, yeah, I guess you could say that as well. Would you agree that getting a king on the big coin, getting a head on the big coin, is there's no overlap in getting, a head on the little coin?
Because they're both different types of coins.
But different kinds of coins. So in that kind of story, you wouldn't expect any overlap anyway. So that's maybe why you're thinking that they're so similar, because independent events tend to be mutually exclusive. Agreed?
Yes.
So let me show you why that's, although the majority of the time that's the case, let me show you why it's not always the case.
So for that one, I also tried putting in the yes, they are mutually exclusive since the outcome of one coin does not prevent any of the outcomes for the other coin.
Good, but that is not mutually exclusive. That is independence you've just described.
But I also did the yes, they are mutually exclusive since the outcome for one coin prevents that same outcome from occurring on the other coin, which is what I did
Let
first.
me see that. Show me what you wrote. Is your answer?
I'll share it with you again. Because I did both of those, which is what I felt was right, which is why I was confused to why
Okay.
it wasn't working.
Right. So let's. So we'll start. Is it the A, the top one we want to do now?
And just to see, because this one I figured out. So, and we talked about the independence,
Right.
because one of them doesn't affect the other one, just like the
Right,
king and
that's
the
it.
queen.
So which other answer in that list did you think it was? Are you comfortable that's the only one that makes sense now?
Yes, for the independent one, I get
Okay, let's
that
move
one.
on to, let's go to C, because I haven't even talked about complementary events. Right.
Okay.
Yes, they are mutually exclusive, and then it doesn't prevent any of the outcomes of the other coin. Yes, they're mutually exclusive, and one coin prevents not. No, they are not mutually exclusive. No, they are not. It is not. Well, I see what you're getting at. They are mutually exclusive.
But then I did that one, and I think it told me it was wrong too. I might have just used up all my tries doing that. We'll see. Maybe I didn't actually guess that yet. Maybe I wanted to ask you. Yeah, it told me it was wrong too.
Okay, let me go and figure out what their answer is. It sounds to me like it's just semantics, that the way they're phrasing it, they expect a particular like formal definition.
Yeah, I think that's why it confused me on the other ones I was trying to do too, because I read it and that's what it seemed like it would be, because they're different ones. But then I felt like I wasn't understanding it.
No, I think yeah, it sounds like you've got a good grasp of that. You're my first, you're in my second. Tell me you're in it. Yes, and now you've got the C thing.
CHY. Yeah, I
That's
don't
the
know
one.
how I can change that on my Skype. Or
I think if you contact the college records and registration, they may need some kind of, oh God, probably some kind of proof that you're not just changing your name because you owe people a lot of money or something. I know. Not that you would. Okay, let's do A. Click on it. And this is question, what is this question? Number 3.
Yes.
Oh, they are being very lawyer-esque. The correct answer for C is the second one.
That's what I did.
And oh no, that's what. Sorry, it's the third one. And let's. Yeah, I can't count dots. It's the third one. It says no, they are not mutually exclusive. So the outcome of one coin doesn't prevent any of the outcomes for the other coin. That is a ridiculously stupid definition. But that's the one they're using. Have you run 80 points? Shots?
Sorry?
Did you run out of tries?
I don't think so. I have one more, I think.
Okay, so the one you're going to put in there is going to be that one then. And make sure it's the correct dot. It's the third one, the middle one, right?
So they're not
Okay.
mutually exclusive since the outcome of one coin doesn't prevent any of the outcomes from the other one.
And that doesn't make sense.
Okay, good.
But I want you, you might find that that sentence is in their little lexicon of this is mutually exclusive, this is the dictionary version of it. And so they were just expecting you to go there, read the dictionary version and come back and pick the answer that looked like their little lexicon of this is the formal way of describing it. That's not how my brain works. I don't see mutually exclusive means that you've got two different events and nothing in the first one is shared by the second. And those are mutually exclusive events. And so those, in my opinion, are mutually exclusive. Right, now we have to talk about the third one of the three.
Yes.
And the third one of the three was complementary events, is that right?
Yeah, and I think I have the same type of question that I couldn't get in this chapter B part.
So what number is this?
It's chapter 7, part B,
Oh,
number
we're in a different
13.
section. Okay,
And that's where I actually got the complementary one wrong. So that would be a good one to go to too.
Okay,
It's the same one actually.
right. So 7A or 7B?
7B.
7B. Okay, I'm still finding. I have to go out 2 windows and back 1 before I can get what you're looking at. Okay, so this is you getting really close to finishing the probability stuff, right?
Yeah.
You're getting there. And 13. Click. Okay, so the complementary events. So what are these events? Oh, it's not the nickel and penny. Okay. This time I'm going to be agreeing with them. It is the fourth dot. They are not complementary.
So would you mind going over the complementary? Because it's when so complementary basically is that there's no overlap. So it can't be like the king and red, it can only be the king and the queen, right?
It's a little bit more than that.
Okay.
So let's show you. We'll use cards again because they're a good situation. 2 events are complementary. We'll call them A and AC. And we'll describe AC as being all the situations that are not in A. You could also think of AC as being the opposite of A. It's a nice shorter way of looking at it. So, to give you an example of complementary events. The first thing about complementary events is that the 2 events have to be in the same world. They both have to be from a single deck of cards, or from one toss of a coin, or one single roll of a dice. You can't have complementary events where you roll a dice and then you pick a card, right? The two events are have no connection. They are never going to be complementary, right? In my world, they would be mutually exclusive. We may have to argue about that one as far as this textbook is concerned. So here's an example. If A was picking a red card, its complement, called AC, would be a black card. Because in a deck of cards, you're either red or you're black. If A was being a king, then the complementary event would be not being a king. So that would be everything else. Ace, jack, queen, 1, 2, 3, 4, 5, all that stuff. If A was getting an even number on a dice, then the complementary event would be not getting that, which would be what? Getting an odd number on a dice. If A was being born on a weekend, then the complementary event would be born on the weekend weekday. You see that they're like left and right-handed. There is no bits left over that don't belong in one or the other. You have to be in this or you're going to be in the complement, right?
So they're basically opposites.
Basically opposite. So to give you an example of something that's not complementary events, A is clubs, B is diamonds. They are not complementary events, because couldn't you get the other two suits as well? But A is clubs and B is not clubs. Those two events would be complementary. And all the events have to share a common pool of like sub-events. You know, when I talk about a card, there are 52 cards in a deck, right? So there are 52 little baby events. And event A is all the red cards, right? Or all the kings, or all the clubs, right? And the complementary then is the opposite of whatever A is, right? What's not A is in the complement of A.
Mm-hmm.
Now that is helpful, because if someone tells me A and A has a probability of 0.3, then even if I don't know what the story is, I can tell you it's complementary is guaranteed to be 0.7. Because won't those two events be separate but add up to 1?
Yes.
And sometimes you use this in some of the probability questions, where they tell you the probability that Janice caught the plane was 90%. And then you need to know what's the chance that she missed the plane, right? She came late. Well, if you made it 90% of the time, won't you miss it 10% of the time? Because, you know, they're complementary events. Now, complementary events are also mutually exclusive. All of them. Does that make sense why they would be mutually exclusive?
Yes, because if it has to be the opposites, they won't be sharing any values.
Correct.
Yeah.
That's it.
Yes, perfect. So for the coin one, applying this, they would not be complementary because they apply to different random circumstances.
Yes.
And
Yes.
then, perfect. Yay.
It's sometimes when you read these mutually exclusive, independent and complementary events, it's almost like you're reading a lawyer's brief. You know, each word it's very, you know, they're being really nitpicky about what is and isn't independent, or what is or isn't complementary.
Yeah.
And just to make things awkward, some pairs of events can be both complementary and mutually exclusive. In fact, those two are always the case. But can't you also have independent events that are not mutually exclusive?
Yes.
Right. I'll show you one.
Okay, perfect.
A is red cards. and B is getting a king. Okay. Now, those two events are not mutually exclusive. Would you agree that there are two kings that are red, right? So we know they're not mutually exclusive, but they are independent events. So let's prove it to you. What's the probability that you get A given that it was B? Now, if the answer to that is the same thing as the probability of A, then aren't these two events, A and B, considered to be independent of each other? Remember, that's one of my two definitions of independence, right? I could do the other version of it. A given B. That's the same one. The other way around also is true.
So
B
is
given
it
A.
because is it because one of the cards could also be black and not be red?
The independence is coming from the fact that what's the chances, what's the probability that I get a red card, right? Let's look at it slowly. So the probability that I get a red card, well, there are 26 red out of 52. So the chances of that happening are half the time, right? Now, what's the probability that I get a red card given that it was a king? So if you tell me a piece of information, in this case, I'm telling you that the card was a king. If that has an effect on the probability, then they are not independent events. If it has no effect on this, in other words, the answer is still a half, then we consider these two things to be independent events. In other words, one doesn't directly affect the other. So let's see what would happen. If I tell you it's a king, that makes them, there are only 4 cards in, right? Of those 4 kings, how many are red?
2.
And what does that simplify down to?
Yeah.
So do you see that red cards and kings are not mutually exclusive?
Mm-hmm.
But red cards and getting a king are considered independent of events because one happening does not directly affect the other. If I tell you it's a king, it doesn't change my chances of getting a red card. If I tell you it's a red card, it doesn't change my chances that I'm going to get a king. So if you don't affect me, you're independent events.
Okay, perfect. I wrote that down too.
Okay, are we good?
Yes.
Are there any more questions in that section before we move on?
I had so I guess this one is kind of related. It's number 15 for that one, which is the mutually exclusive.
Okay, so this one is quite innocent. Suppose two events A or B are mutually exclusive. Okay, and the probability of A is a fifth, and the probability of B is a half. Are A and B independent? Right. Well, let's find out. What's the probability of A given B? It's a bad pen. So let's put the words into that. What's the probability? Well, since A and B are mutually exclusive, if I tell you B has happened, doesn't that mean there's no chance of A happening? Right. Can you imagine this is A and this is B? And I'm asking you, what's the probability that I get A given that B has happened? Well, if one of these things has happened, isn't there zero chance that anything in A can happen? Because the two groups of events are mutually exclusive.
Oh, so because B can't happen, A can't happen either.
Right. If one of them happens, the other can't, right? So if B is happening, A can't. The probability is going to be 0. right? Now, what is the probability of A? Well, the probability of A is a fifth. Do you see that these two are not equal? So A and B are not independent. So we're doing the test. There are two tests. This is one of the tests we're using. And the test says, if the probability of A given B is the same number as the probability of A, they're independent. Right? A and B are independent. Obviously then, if it's not equal to it, as it was in this case, then they're not independent. So we can use that as a very quick test on are two events independent. Can we find this guy? Can we find or know this guy? If these two numbers are the same, they're independent, even if they don't look like they should be. If this number and that number are the same number, they are independent. Yet on the other hand, if they are different, which they clearly are in this case, they are not independent.
So then they are dependent on each other. And they're dependent on each
No,
other.
yeah, not independent is, I don't know, does this book call not independent dependent? They might actually use that phrase. It's the same thing, right? Not independent is dependent. I'm not sure whether this particular textbook uses the word dependent or not. And I'm looking, and they do. They use dependent.
They're dependent.
Yeah.
And then looking at it being a complementary event.
Which means then that can't we find the probability of A plus the probability of B? When you're independent, right?
Mm-hmm.
We know that this is the first answer. Add the second answer, which comes to that. So if they were, let's phrase it this way, if these two events were complementary, right? Mm-hmm. What would the value of P of A plus P of B be? Well, if they were complementary, don't they always add up to 1?
Yes.
Don't these two not add up to 1?
Yeah.
So doesn't that mean that they cannot be mutually exclusive? They're not mutually exclusive. If these two guys did add up to 1, wouldn't we then be able to say mutually exclusive?
So they're also not complementary, right? Because they're not covering the entire.
They're not complementary. I used the word mutually exclusive. I'm wrong. My brain was saying complementary, but my vocal cords decided to say the other one.
All right. Oh, perfect.
You are correct. The fact that you corrected me is good because that means you know what I was trying to say.
Yes, and so I think I'm getting it now. I think they were just seeming similar, just reading off of it, but like seeing like the nitpicky details of it, I'm getting like what it is that's different.
Right. So mutually exclusive, complementary, and independent are different things, right? Different concepts. Mm-hmm. And you feel a bit more comfortable about which of the three situations it could be.
Yes, I do.
And you're also happy that you could be both two things at once.
Yes, very excited about that.
Right. So you could be independent and mutually exclusive, right? You don't need to be, but you could be. And in some cases, you are. Aren't all get this the right way around. Aren't all complementary events mutually exclusive by their nature?
Yes, because you can't have anything else in there.
Right, but the reverse direction isn't always true. Can't you be mutually exclusive? Two events can be mutually exclusive but don't necessarily have to be complementary events.
Yes,
Aren't clubs and hearts mutually exclusive? But clubs and hearts are not complementary events.
because you could have the other
You could
two.
have others, the other two, exactly.